All right, guys, today I am going to do the experiment for those of you who were not able to get supplies or for those who were not able to attend class. So first of all, I got all my supplies ready so that I can do this. I have flour, I have sugar, I have salt. In my bag, I have cornstarch. More than likely, you actually have a container of that. I have baking soda. I also should have yeast. I do not have it. Honestly, I forgot to get that for you guys. So I'll tell you the results of yeast for those who do not have it. I also have vinegar. And what I did with my vinegar is I poured it into a measuring cup just so it's more accessible than having to pour it out of the big container. I also have a glass of water. And I do suggest that you use glass today just so that you can see it. So vinegar and water. In terms of supplies, you need something to mix in. So I had the mixed trays. You might have some other things if you want to use like a measuring spoon or a measuring cup to do that. You can do that in a tiny little bowl, but you're not going to have a lot of each sample, so you don't need a big, huge container in order to do some mixing. Some of the other things that I have are something to mix with. So I have the Chem Scoops. You can use toothpicks, you can use a spoon, but something that's going to help you get the samples and then help stir them up. Some other things that I have here. I have a teaspoon. Now, what's great about a teaspoon is that if you do not have a graduated cylinder, which you probably do not have sitting at home, a teaspoon is about 5 milliliters. So that would be the perfect tool to use. I also have 2 tablespoon cup here or spoon to help you if you need to get some of the materials. Now, there are a couple additional things that I do not require you to get. I have a magnifying lens. I have iodine. I also have something called pH paper. And this is something we use a lot this year, but I did not ask you guys to get this. I have a lot of it at school. So I'm going to share how to use pH paper today. So we're going to get started. And the first substance on your list is flour. So what I'm going to do is I'm going to take a very small amount. Now it says pea size in your directions. So this Chem Scoop is about pea sized. So what I'm going to do is I'm going to go into my giant flour container. And like I said, you can end up with a lot. But I did not put a lot on this Chem Scoop. I'm going to put it into my mixing tray. And I'm going to observe it first. So when I look at flour, what I see is white. It's a powder. So I'm going to record that in my chart. The next thing I need to do is add some water to test its solubility. So what I'm going to do is I'm going to take the teaspoon. I'm going to take 1 teaspoon of water, which is about 5 milliliters, and I'm going to pour it in there with my sample. And once again, it's perfect in this mixing tray because it fills it up just right. So now I stir, and I'm going to look at my flour. And what I see is it is soluble. So flour is water soluble. But if I actually looked at this in a test tube where I can see through, because normally I'd put in a test tube and I'd shake it, I will see that it's kind of lumpy. So even though it's soluble with water, we get kind of a lumpy context with it. So flour is soluble. Now I take this water sample and I'm going to take one of my pH strips. pH tells us if it's an acid or a base. So I'm going to dip it in there, and you just dip it for a second and pull it out. So I'm going to pull it in and out, and my color is changing. And what I'm going to do is I'm going to match it up. Now I am landing at about a 7 with my pH for flour. This can change depending on your water and where you get your water from. Now today we're just doing it from the tap. If we were doing this as a science experiment, I would actually use distilled water. But my pH is a 7. I am now done with this test strip. I'm going to get rid of it. The next thing you need to do is get another sample of powder. Another sample of flour. So I'm going to get a little more flour. Once again, you don't need a lot of it. And I'm going to test its reaction. So I put that in my tray. I'm going to test its reaction with the vinegar. Now, you're going to see a reaction right away if it does react with vinegar. So I'm going to take, once again, I'm only going to do half a teaspoon here. And I'm going to pour it and nothing happened. If there is a reaction, it will fizz. I have no fizz there. Okay, now the next thing I'm going to do is I'm going to try a sample again, and this time I'm going to try it with iodine. Now, iodine normally has a yellowish brown color to it. You can kind of see that in the tray here, or in the dropper. I'm going to put about 5 drops in there. And when I put flour in there, this changed right away. I don't know if you can see it, but it is a blue-black color. So that's what I would record for its reaction with iodine. It turns blue or black. And I have now tested everything I need to for flour. Now, if I see anything else, I could record observations. I don't see anything significant here. And so that was just the flour test. Now, the next one I'm going to do is the sugar. Now, here's the thing with sugar versus salt. Both sugar and salt, so I'm going to take a little sample of the sugar. Both sugar and salt are crystals. And when you look at a crystal, when you look at it closely, you can see different shapes. Now, my sugar does not want to come out pretty well, so I'm going to take a little bit from my scooper here. And I'm just going to put, once again, just a tiny little sample in 3 of the trays here of my sugar. Now, sugar, like I said, is a crystal, but it's an irregular crystal. So that means if I put every little sugar sample underneath there, I'm going to see a bunch of different shapes. Okay, it's not a very uniform shape. So the first thing I do now is I'm going to do the water. So I'm going to take 5 milliliters or a teaspoon, and I'm going to pour that in there. Okay, I am going to stir it up. Now, in this tray, you may not actually see the solubility, but you know you can make sugar water, right? So sugar water is soluble. So this is, water is soluble. Now I'm going to take my pH strip, drop it in there, pull it out. And for this one, I'm going between a 6 and a 7. I'm going to say 7 for sugar. So the pH of sugar is 7. It is soluble. Now I'm going to put a little bit of vinegar in there, see if there's a reaction with the vinegar. Once again, no fizz, not exciting. It doesn't react with the vinegar. But now I'm going to put the iodine. I'll do about 5 drops. And here's where you see the difference. So when we did it with flour, we saw more of a blue-black color. Well, when I do it with sugar, I get more of a yellow-orange color. So it stains a pale yellow, a pale orange, and that is what it reacts with for iodine. Once again, I don't see anything special about sugar, minus the fact it's crystal. I've done with my testing for sugar. Now I'm going to get to salt. Okay, now salt, once again, I said it was a crystal. So I'm going to pour a little salt into 3 different sections here. And I'm going to take a look at it. Now here's the thing with salt. Salt is a crystal, but it is cubic shaped. So that's really how you can tell the difference between salt and sugar. Now here's the tempting piece. You guys are all working with kitchen items. Never do this in a science lab. Never, because a lot of times it's not salt and sugar, but people like to do the taste test. So they'll lick it, they'll see if it's salt, they'll lick it, see if it's sugar. But truly, once again, that's not good safety. You should be using a microscope or a magnifying lens to kind of look at that cubic shape, and you'll see that salt is more square. Okay, so that's one way you can tell the difference between salt and sugar. So I'm going to go ahead and do my water again. Now, you guys should know the answer to this without even doing it. When you mix salt and water, you get salt water, so it is soluble. When I do my pH strip, once again, pull it out. I'm getting a very strong 7 there, and that is the pH of salt. The next one is to take the vinegar. I'm going to take this with a little bit of vinegar, pour it. Nothing exciting. I know everybody wants the exciting part for that. And now so there was no fizz for putting vinegar, but now I'm going to put the iodine. And salt also stains a pale yellow. So I've got the pale yellow color. So that's the reaction with iodine. Now we're going to get into two other things. Now I'm going to do cornstarch. Now before I do that, I'm going to clean off this scoop just so it's not contaminated. And now I'm going to take my cornstarch. Now, like I said, you guys probably have a container of cornstarch. I buy a lot of organic materials, so mine comes in a bag. So I'm going to put a sample of cornstarch, and another little sample of cornstarch. Now here's the thing with cornstarch. Cornstarch looks a lot like flour. A lot of people confuse it just by doing a visual test. A lot of people think that cornstarch is flour or flour is cornstarch, but there is a difference when you actually start to do some testing. Now it is a white powder, okay, so you can put that under your physical characteristics. I'm going to go ahead and put it with some water. So I'll grab my 5 milliliters. I'm going to pour, and I'm going to stir. Now, when I put water and flour together, I got a very lumpy substance. When I put water and cornstarch together, it actually gets to be very smooth. So cornstarch is water soluble, but instead of getting lumpy like flour, cornstarch gets to a smooth texture. Okay, so that's a big difference in a way to tell the difference between cornstarch. I'm going to do my pH test with that. Now for cornstarch, I got a pH of 8. So there is another way to tell the difference between cornstarch and flour, is in the pH level when it is mixed with water. I'm going to go ahead and put my vinegar. Nothing exciting, same thing. Now I'm going to put my iodine. You can kind of take a guess based on what we saw from flour, but iodine does the same thing. It turns a black-blue color. Okay, so now we've got everything tested for the cornstarch. Once again, big difference between cornstarch and flour is in the fact that the pHs are different, and when you mix them together, one is more smooth and one is more lumpy. Now we're going to get to our last one, which is kind of the fun one. That's baking soda. Now you guys know stuff about baking soda already. Let me get another clean scoop here. We use baking soda for cleaning things and for doing the volcano experiment. So I'm going to take a little bit of baking soda. I'm going to look at it. Now baking soda is a powder, but you'll notice that the consistency of the powder is a little bit different than when you look at like flour or when you look at cornstarch. So it's kind of more of a fine powder. It's more, you can see the different parts to it. So now I'm going to add my water to my baking soda. And I'm going to stir it up. Once again, baking soda is soluble. We can mix it with water. So we have solubility there. I'm going to take the pH. Now baking soda for its pH, actually you can even see this, it's a darker green. So its pH is 8. So we have a pH of 8 for baking soda. Now I'm going to put the vinegar. And this one, I want to see if I can show you a little closer here. When you put baking soda and vinegar, we definitely get a fizz. Those two react together. That's why they actually use it for those volcanoes. Baking soda will always give you a fizz. So that's kind of the fun one. It's one of the ones that are easier to identify because of that piece. The last thing I'm going to do here is put some iodine. And when I put iodine with baking soda, I'm back to a pale yellow. Now, I did add one more thing in there that you're supposed to test, and that was yeast. Now, I do not have any yeast today, but the reason why I like you to use yeast to see is it's a substance we will use throughout the class because it is a living thing. With yeast, you're going to see that it's grainy. A lot of people don't know what yeast even looks like. So if you have yeast, I want you to go ahead and pour it out, or pour it into your sample just so you can see it. And with yeast, you should see that it's more grainy. It's more granular. If I did a pH test, I'm going to get about a 7. It is soluble with water because we have to mix it up to make bread, right? But it's not soluble right away. It takes some time to become soluble. So if we did the test really fast, we're not going to see the solubility. There is no reaction with the vinegar, and it stains a pale yellow. One other thing I want to show you, since we have all this stuff here, is pH of vinegar. So I'm going to take some vinegar, and I'm going to pour it into my container here. And I'm going to get myself a new pH strip. Okay, got that. So we were seeing a lot of yellows, some greens, but if I put vinegar, you're actually going to see that it turns more of a reddish color. I get a pH level of 3. Anything that's going up on the higher scale there, like 1, 2, 3, that means it's very acidic. When I do pH and it comes more towards a 14, 13, 12, that's very basic. Now, a lot of people think that basic is not dangerous. Basic can harm you. It can also burn you. So just don't think of acids as something that is very strong. Bases can be very strong too. What we really want is neutral. 7 is neutral. Water should be a 7 when we test pH. So that means that it's not going toward the acidic level. It's not going towards the basic level. It's kind of a healthy level. Okay, so that's a little information for pH. We will do more experiments with pH. When we get back to school, I will hopefully be able to give you guys each a little tube so that you can take it home and do some testing. All right, so that is our experiment for today. I know it wasn't a big bang and all that stuff, but I wanted you to start working with these substances and get used to the techniques that we use today. But you can do this with definitely things in your house. Now, what we'll be doing is we'll be taking this to the next level. When we do crime solving, we're not going to work with just kitchen items. We're going to throw things in like gypsum and calcium carbonate. Now, if some of you guys got some of these extra things, Alka-Seltzer is really fun to test. If you got vitamin C, go ahead and test that. You might not realize vitamin C is a white powder. But if you bought anything else to test, go ahead and try those tests, and you can add that into your chart. Otherwise, please go ahead and just put your chart together and turn that into Google Classroom. If you guys have any questions, let me know.